Do you remember how all of the examples we've done so far said assume that the variables represent non-negative real numbers only? Well, sometimes the variables can represent any real number. And so what we need to remember is that taking the even root, so the square root, the fourth root, the sixth root, that has to have a result which is positive only. So when we're finding the nth root of a to the n, if n, the index, is even, then we're going to make sure that our result is within absolute value to make sure that it is positive. If our index is odd, then it doesn't matter. It is what it is, so we're not going to worry about that, just the even roots. So our first example, the square root of negative 5 squared, is what's inside, but it has to be in absolute value bars because it is an even root. So this square root would be 5. For b, x to the 6th, so I'm looking for a number that multiplies by itself to be x to the 6th, so that has to be 6 divided by 2, making those exponents 3. But it's an even root, so it's got to be absolute value. And I don't know what x is. It can be any real number, and that's the problem. So I'm going to keep that answer within the absolute value bars. It'll depend on what x is. If it's a negative number, then this will just have to be positive. And that's what the absolute value bars will do for us. In C, we want the fourth root of x plus 6 to the fourth. So we just remove the rooting, because the fourth root and the fourth power, those functions cancel each other out, leaving what's inside. But it is an even root, so it must be an absolute value. And again, I don't know what x is, so depending on what that is, this number could be negative or positive, so I need to leave it in the absolute value bars to ensure that it will stay positive. Example D, when we take the third root of a number to the third power, we'll cancel out, leaving just what's inside. But this is an odd root, so that means it is what it is. That will work out just fine to be negative 3. For E, we want the fifth root of a to the 5th, so we cancel out the root and the exponent. And it's an odd root, so it doesn't matter. I don't need to ensure this is positive. It is what it is. F is a little strange because it's the square root of all of this, not just a something squared. So my first job here is to make sure this becomes something squared. Otherwise, I can't take the square root of something to the second. So I need to factor this. Is it a perfect square trinomial? Well, I think it is, because the first term is squared and the last term is squared. So is that the square roots of that? That'll add up to a positive 6. Let's see. Positive 3x, it does. So this is x plus 3 factor twice. So now I've written it as the nth root of a to the n. I can cancel out the squaring and the square root. So that leaves what's inside, x plus 3, but it is a square root, right? Even root. So this needs to be the absolute value, because I don't know if x is gonna be a positive or negative number. It can represent any real numbers, so I need to make sure that this result will be positive only. And the only time we worry about that is when the variable represents any real number. If it says positive or non-negative numbers only, it's not a big deal. It's only when it can represent any real number that we need to make sure we correct for the even roots here.